Data science leverages statistical analysis, machine learning, and domain expertise to transform raw data into actionable insights. By identifying patterns and trends, it enables businesses to make informed decisions, optimize operations, and drive innovation. This interdisciplinary approach is crucial for gaining a competitive edge in today's data-centric landscape.
Data science integrates statistics, computer science, and domain expertise to revolutionize decision-making. It transforms raw data into actionable insights, enabling industries to understand complex patterns and drive innovation. By leveraging statistical methods, computational frameworks, and domain applications, data science provides a comprehensive approach to solving real-world problems. Data science integrates scientific methods, processes, algorithms, and systems to extract insights from data. It relies on statistical methods to identify patterns and quantify uncertainty, while computational frameworks use algorithms to analyze complex datasets. These insights are applied to solve business problems and drive innovation, making data science a powerful tool in today's data-driven world. The surge in digital data offers immense potential for transforming operations and creating value. By 2026, 11.5 million data science job openings are expected, highlighting its growing importance. Shell's predictive maintenance saves $15 million annually, and 89% of companies report competitive advantages from data science investments. As Thomas H. Davenport notes, every company will engage with big data. The data science process involves transforming raw data into actionable insights through a systematic approach. This includes collecting data from various sources, preparing it by cleaning and normalizing, exploring it for patterns, modeling with machine learning algorithms, and deploying solutions to test accuracy and implement in real-world settings. The data science workflow involves collecting raw data from sources such as social media and sensors. Preparation includes cleaning and normalizing data. Exploration identifies patterns and anomalies. Modeling uses machine learning to build predictive models. Finally, deployment tests model accuracy and implements solutions in real-world scenarios. Pitt, Ohio revolutionized delivery times by leveraging data science. They collected GPS data, traffic patterns, and historical records to identify variables affecting delivery times. Predictive models, including weather and seasonal factors, achieved 99% accuracy, enhancing customer satisfaction and operational efficiency. This data-driven approach significantly improved prediction accuracy, showcasing the power of data science in logistics. Data science involves understanding core concepts like data collection, cleaning, and analysis. Key challenges include managing data quality, ensuring privacy, and balancing model complexity. Trade-offs often arise between model accuracy and interpretability, requiring careful consideration of bias and variance. Effective data science practices lead to actionable insights and informed decision-making. High-bias models, like linear models for complex data, underfit by missing key patterns, resulting in poor performance. High-variance models, such as deep neural networks with limited data, overfit by capturing noise, excelling in training but failing on new data. Achieving optimal balance through cross-validation, regularization, and ensemble methods enhances generalization. Parametric models, like linear and logistic regression, have a fixed structure with predetermined parameters, making them simple and interpretable, but limited in flexibility. Non-parametric models, such as decision trees and neural networks, adapt to data, capturing complex relationships, but risk overfitting and require more data. Understanding these differences is crucial for model selection. Data science thrives on powerful tools and technologies. Python, with libraries like pandas and NumPy, is essential for data manipulation. R is preferred for statistical analysis. Apache Spark and Hadoop handle big data efficiently. Visualization tools like Tableau and Power BI simplify data insights. Machine learning frameworks such as TensorFlow and scikit-learn enable advanced analytics.
Python, with libraries like pandas and NumPy, leads in data manipulation, while R specializes in statistical analysis. Apache Spark and Hadoop handle big data processing. Visualization tools like Tableau and Power BI simplify data insights. TensorFlow and scikit-learn drive machine learning advancements. Cargill's app exemplifies data science's impact, boosting shrimp farming efficiency by 30%. Data science is revolutionizing industries by enhancing decision-making and efficiency. In healthcare, predictive models reduce hospital readmissions by 25%. Finance benefits from algorithms that detect fraud in milliseconds, saving billions. Retail sees 35% of Amazon's revenue driven by recommendation engines. Transportation leverages self-driving vehicles processing 1 terabyte of data hourly for safe navigation.
In healthcare, predictive models identify high-risk patients, reducing hospital readmissions by up to 25%. In finance, advanced algorithms detect fraud in milliseconds, saving billions. Retail benefits from recommendation engines, driving 35% of Amazon's revenue. Transportation sees self-driving vehicles processing 1 terabyte of sensor data hourly for safe navigation and route optimization. AutoML simplifies model building, making data science accessible to more people. Ethical AI frameworks ensure algorithms are fair and transparent. Edge computing processes data locally, reducing latency for real-time applications. Data literacy is crucial across roles. Continuous learning is key to success in this evolving field. Transform data into actionable insights.